Imagine it is the year 1901. A group of sponge divers is exploring the seafloor near a small Greek island called Antikythera. In the deep, dark water, they stumble upon the wreck of an ancient Roman cargo ship. It is a treasure hunter's dream, filled with beautiful statues of bronze and marble, fine glassware, and coins. As they carefully bring these artifacts to the surface, one discovery seems less impressive than the others. It is just a lump of corroded bronze and wood, about the size of a large book, shattered into many pieces. It looks like something that has been melted and twisted by time and the sea. It is set aside with the other items, considered just another broken relic. For nearly a year, this strange object sits in a museum storage room in Athens. No one knows what to make of it. Then, one day, a museum archaeologist notices that one of the fragments has something remarkable on it. It is a gear. A carefully crafted, precision gear made of bronze. This simple observation sends a shockwave through the small community of historians who study the ancient world. Why would a complex gear be inside a lump of rock and bronze that is over 2,000 years old? Everyone knew that the ancient Greeks were brilliant philosophers and artists, but the technology of intricate gear systems, like those found in clocks, was not supposed to exist until over 1,000 years later, in the Middle Ages. This unassuming lump, which we now call the Antikythera Mechanism, became one of the most important archaeological discoveries ever made. It was not a statue or a weapon, but a machine. A machine that should not have existed. Its discovery forced us to completely rewrite our understanding of ancient Greek technology and hinted at a level of scientific sophistication that was lost for centuries. So, what exactly was this mysterious device? For decades, scientists used X-rays to peer inside the corroded fragments. What they saw was breathtaking. It was not just one or two gears, it was an incredibly complex assembly of at least 30 precise, interlocking bronze gears, all working together like a sophisticated machine. It was so intricate that nothing like it would be seen again until the 14th century. Researchers began to call it the world's first analog computer. But what was this computer designed to do? The answer is written on the device itself. Using advanced imaging techniques, scientists were able to read thousands of tiny, hidden Greek inscriptions on the mechanism's surfaces. These were like a user's manual carved into the bronze. The text described the movements of the sun, the moon, and the planets. It talked about eclipses and the timings of ancient games, like the Olympics. The Antikythera Mechanism was a cosmic calculator. By turning a hand crank on the side, the user could set a specific date, and the gears would spin into position, displaying the positions of all the known celestial bodies on that exact day. It could predict solar and lunar eclipses with remarkable accuracy. Imagine a philosopher or a ship captain 2,000 years ago, holding this device and being able to know the future state of the heavens. It was a physical model of the Greek understanding of the universe, a universe that was not run by magic, but by predictable, mechanical laws. This one device proves that the Greeks were not just thinking about the stars, they were building machines to simulate them. The Antikythera Mechanism did not appear out of nowhere. It was the pinnacle of a culture that was obsessed with understanding the world through mechanics and mathematics. We have writings from other brilliant Greek engineers that describe inventions so advanced, they sound like they are from a science fiction story. One of these men was Heron of Alexandria. He described a device called an eolipile, which was essentially the world's first steam engine. It was a metal sphere mounted on a boiler. When the water boiled, steam shot out of two bent pipes, causing the sphere to spin rapidly. It was a simple turbine. The ancient Greeks had invented a working steam engine, but they saw it as a fascinating toy or a temple wonder, not as something that could power factories or ships. They had the technology, but not the industrial vision to apply it on a large scale. Another incredible invention was the automatic door. Hero also designed a system where a fire on a temple altar would heat the air inside a sealed container. The expanding air would push water into a bucket, which, as it became heavier, would pull ropes and pulleys to open the temple doors. To a worshipper, it would seem like a divine miracle. The gods themselves were opening the doors. But in reality, it was pure physics and engineering. These stories show us that the Greeks possessed a deep knowledge of principles like pneumatics, using air pressure, and hydraulics, using water pressure. They were master tinkerers and inventors. They combined art with engineering to create marvels that entertained, inspired, and served religious purposes. The Antikythera Mechanism was not a magical anomaly, it was the logical result of a society that celebrated and advanced mechanical innovation. Beyond clever toys and temple wonders, the ancient Greeks also applied their engineering genius to solve big, practical problems. They built massive machines that powered entire industries. One of the most important of these was the water mill. While many people think water mills became common in medieval Europe, the Greeks were using them centuries earlier. A Greek engineer in the 1st century before Christ described a water wheel that was used to power a grain mill. But they did not stop there. They developed a much more complex machine called the reverse overshot water wheel. This was used in the silver mines of Laurion, where Athens got much of its wealth. This was not a simple wheel in a stream. It was a complex system where water was collected at the top of a mine and then channeled down to a wheel in a closed loop. The weight of the water in the buckets of the wheel would make it turn, and this power was used to crush silver ore or to pump water out of the deeper parts of the mine. It was an industrial machine, operating on a massive scale. Furthermore, they used fire in incredible ways. The famous Greek fire, a terrifying weapon used by the Byzantine Empire, the eastern continuation of the Roman Empire, which was deeply Greek in culture, was a pressurized nozzle that shot a burning liquid that could not be put out with water. It was like an ancient flamethrower, and it was decisive in naval battles. These examples show that Greek technology was not just theoretical. It was used to create wealth, to build empires, and to wage war. They were harnessing the fundamental forces of nature, water and fire, in ways that would not become common again for over 1,000 years. This brings us to a haunting question: if the ancient Greeks were so technologically advanced, why did their world not have an industrial revolution? Why did machines like the Antikythera Mechanism and the steam engine disappear? The answer is complex and tragic. The ancient world was a turbulent place, filled with wars, invasions, and the slow collapse of empires. The knowledge of the great engineers was often kept secret, written in scrolls that were stored in great libraries. When the Great Library of Alexandria burned, countless works of science and technology were lost forever. This knowledge was not stored on the internet or in millions of printed books, it was fragile and concentrated in a few places. As the Roman Empire focused more on practical engineering like roads and aqueducts, some of the more theoretical and complex Greek science was forgotten. Later, as the ancient world transitioned into the Middle Ages, economic and social structures changed. Slavery was widespread, which reduced the need for labor-saving machines. There was no large, interconnected industrial system that could support and fund the development of technologies like the steam engine. The secrets of devices like the Antikythera Mechanism were likely known only to a small group of craftsmen and philosophers, and when they died, the knowledge died with them. It was a dark age for technology, where a 1,000-year gap opened up between the invention of these machines and their eventual reinvention. The legacy of Greek engineering was shattered, its pieces scattered like the fragments of the Antikythera Mechanism itself, waiting at the bottom of the sea to be rediscovered. The story of ancient Greek technology is not just about the past, it is about how we view progress and our own future. The discovery of the Antikythera Mechanism forced historians to abandon the simple idea that technology moves in a straight, constantly upward line. Instead, it shows that innovation can be cyclical. Great leaps forward can be made, only to be lost to time, and then rediscovered centuries later. The Greeks were on the verge of a scientific and industrial revolution 2,000 years before it actually happened in Europe. They had the minds, the tools, and the ideas. What does this tell us? It teaches us humility. Our modern world, with its computers and spaceships, might seem like the peak of human achievement, but the story of the Greeks shows that the potential for incredible innovation has always existed within the human mind. It also makes us wonder, what other ideas from the ancient world have we yet to discover? Are there lost inventions buried in the desert or at the bottom of the sea that could inspire us today? Furthermore, it challenges us to protect our own knowledge. In a digital age, could our own technology become as lost and unreadable as the scrolls of Alexandria? The Antikythera Mechanism is more than an artifact, it is a message from the past. It tells us that human genius is timeless, and that the line between ancient and modern is much thinner, and much more fascinating, than we ever imagined.